Welcome to Differentiation Rules. Today we're going to be speaking about one of the basic rules of differentiation called the power rule. Now, in other classes we've looked at the formal definition of a limit and using that definition of a limit to help us with finding the derivative of a function. And it can be a very long and tedious process. So what we're going to do now for the next several weeks is look at using different types of differentiation rules to help us take derivatives very quickly instead of using that long, tedious definition that we have been looking at. So the first rule we're going to talk about is what's called the power rule. Now, the power rule says for any real number where r is not greater than 0, the derivative with respect to x of x raised to some power n is this. The n gets multiplied out front and we subtract 1 off the power. That's called the power rule. So notice how the exponent gets multiplied to whatever's out front, and then you have to subtract off 1 from the exponent. So that is our power rule. And when we look at just a couple notes, you multiply n to the coefficient in front of x. In this case, if you're looking at it, it would be 1. Then you subtract 1 from the exponent. So what we're going to do is look at a couple of examples that has the power rule. So, example 1. Let's find the derivative of each of these functions. So we're not going to use that rule anymore. Okay, we're going to, the definition of a derivative, what we're going to use is the power rule. So here's a simple function, f of x is equal to x to the 8th. Notice the leading coefficient is 1. So let's take the derivative. F prime of x is going to be equal to the derivative of the function with respect to x of x to the 8th. Now I put that here in purple. So let's apply our power rule. The power of 8 goes out front and gets multiplied to the x. And then we subtract off 1. So this becomes 8x to the 7th. That's the derivative. What that means is this is the expression to find the slope of any tangent line on a given interval of this function. Okay, this is a polynomial function, so all x's are defined. We can use this expression to find the slope of a tangent line at a given point. That's what this means. We just don't know what x is. We don't know the point. But we've applied the power rule and got 8x to the 7th. Let's look at the second example. Now we have g of x is equal to the cube root of x squared. So before we begin taking the derivative, let's just rewrite this using exponents. So we'll get rid of the radical. So g of x is equal to x to the 2/3 power. So now let's apply the power rule. The 2/3 is going to get brought out front. So to find the derivative, g prime of x is equal to d dx of x to the 2/3. The 2/3 goes out front, gets multiplied to the x, and then we have a power that's 2/3 minus 1. Okay, 2/3 minus 1 is negative 1/3, so our answer is 2/3 x to the negative 1/3. Depending on your text, you can leave it with the negative exponent. If you chose not to, this simplifies into being 2 over 3 times the cube root of x. Either answer is okay. Most of the time you can leave the negative power. The last example here with the power rule happens when you have actually a negative power, and this can mess us up a little bit. So for example, if we look at this function h of x equals 1 over x to the 19th, and we wanted to differentiate that. Now I could say it's a fraction, I don't really know. But we can rewrite 1 over x to the 19th as x to the negative 19th power. So that's what we're going to do. Now, once we have this power, let's apply the power rule. So the derivative is equal to d dx of x to the negative 19. Well, that negative 19 goes out front, gets multiplied to x, and then we have to subtract off 1 from the power. Now avoid this common error. You've got to subtract 1. So negative 19 minus 1 equals negative 20. It does not equal negative 18. So that's a common error here when we subtract. Students accidentally add 1 instead of subtract 1. So just be very careful of this. So the negative 19 gets multiplied out front to the x, and negative 19 minus 1 is negative 20. You can leave it as negative 19 times x to the negative 20th, you could simplify that also by bringing the exponent down to the denominator. So this is another simplified form, negative 19 over x to the 20th. All right, a couple more rules of differentiation besides the power rule. Here's three more outlined in purple. And what this really says is that if you're taking the derivative of two functions being added, take the derivative of them separately. That's the idea. So d dx, the derivative of a function with respect to x, of f of x plus g of x is the same thing as taking the derivatives separately and adding them together. The second rule is just the same thing with subtraction. If you're taking the derivative of more than one function, separate them and take the derivatives individually, and we still subtract. Lastly, this is a nice little rule. If you're multiplying a number to a function and you want to take the derivative, bring the number out front and then just multiply it by the derivative. So what we're going to do in the next examples is really look at these three pieces. Example 2, we're going to find the derivative of f of x equals 2x to the 6 plus 3 square root x. So here's the idea. We're going to take this derivative, f prime of x equals the derivative of the first function plus the derivative of the second one. That was the first rule on the previous page. So look at that. This is one function, this is one function. Take the derivative separately. It makes it much easier to look at. So let's go ahead and do that. So now I'm taking the derivative of 2x to the 6th. So I can apply rule 3. Bring the 2 out, take the derivative of just x to the 6th, plus I'm going to bring that 3 out and take the derivative of x to the 1/2, which is the same thing as the square root of x. So that's rule 3. It's important to remember as we go through and take these derivatives, we'll stop writing d dx so much, but I'm doing that just to help you a little bit. Okay? So if we're going to apply the power rule, we're going to take the derivative of x to the 6th, which is just 6x to the 5th. The derivative of x to the 1/2 is 1 over 2 root x. Okay? The 1/2 comes out front, and this would be x to the negative 1/2, or 1 over 2 root x. And then just simplify. 2 times 6 is 12x to the 5th, plus 3 over 2 times root of x. So if you go back to the beginning, and if you look at just this function here, just the power rule, the power rule would say 6 gets multiplied to whatever's out front. 6 times 2 is 12. Subtract 1 off the power, you would have 6x to the 5th. Same thing all the way down. I just did it in multiple steps, just to show you those three rules. Okay? Now, in example 3, it looks like we're going to have to take the derivative of a fraction. Okay, a quotient, but we really haven't talked about that. We've just introduced the power rule, so let's find the derivative. Now, since there's only a single term in the denominator, one of the first things we should do is just divide each term in the numerator by our denominator. So that's what we said here. One term in the denominator, simplify. So this is what I did in the first step before I even took the derivative. Let's break this fraction up. So we have 4x squared over x minus 3x over x plus 2x to the 1/2 divided by x. It's a single term in the denominator, so I can do that. So if this was x plus 4, this would not apply. We'd have to use another method called the quotient rule. But since this is a single term, let's see what we get by dividing each of the terms of the numerator divided by the denominator. So when I simplify, I get 4x minus 3 plus 2x to the negative 1/2. So now I differentiate that. I have to differentiate each of these pieces. So I'm going to do that. So the derivative, if I look at the derivative of 4x, okay, the derivative of 4x is 4. The derivative of a constant is 0. And the derivative of 2x is simply 2 times the derivative of x to the negative 1/2, which becomes negative x to the negative 3/2. So when I simplify these three pieces, the derivative of 4x is 4. The derivative of a constant is 0. And the derivative of 2x to the 1/2, negative 1/2, becomes negative 1x to the 3/2. that negative half times 2 is negative 1. So then I just simplify. I just have to take out the 0 term. Okay, so that is the power rule when we talk about differentiation. If you have any questions or comments, you guys can go ahead and email me, nicholas.bennett@dc.gov. You can also post your questions on the bottom in the comments portion of this video. We'll see you next time.